Um, if you're watching online, sorry, I did not record. You didn't really miss anything except how to do a stem plot and reviewing how to do it in the calculator. Sorry. So we're at percentile as far as your note printout. This drives me crazy because when do you think the first time you ever received a percentile? Where do you get percentiles? Like in your life, in your real world scenario? What? Doctor is one thing. Where else? Anytime you do testing, when you probably started doing those kind of standardized tests when you were like what? Like low elementary school, right? How many people can give me a good definition of what percentile is? And how many other people could have written down that same thing? That's what drives me crazy is why have they never explained that to you? Like you get it all the time and you're like, you're okay with saying I'm this percentile, like I get it kind of, but you should know what that means. So it says the P percentile in a distribution is the value with, this is, and I put a blank underneath it. I want to do it like a fill in the blank. Write it. With P% of, what is that? The observations less than that. That's the fill in the blank part. Now this applies to a whole bunch of things, and it's not always going to be interpreted this way, but my shorthand of percentile is always percent you did better than, just because it's easy to remember it that way. Because when you think of standardized test, you think of the percent that you did better than. A couple things that get funny with that are if it is defined as percent you did better than, what can you technically never be? 100th percentile because you're not better than yourself. But now it gets to when we have such a big group that you're like the 99.9 something, and sometimes groups use 100th percentile. But to the definition, you can't technically be higher than yourself. So we're just going to deal with this super generically here. I left blanks. I was trying to find students that, we don't have any that are single. This first fill in the blank, we might not do all these. Let's say 60 inches tall. You're filling in the 60. How do I figure out your percentile? Based off the definition we just gave.
Take all of the values lower than that and figure out what percent of the total group that is.
So how many are lower than 60? Two. So I'd do what with 2? Which we decided was?
33.
What does 2 divided by 33 give us? Why aren't you working? Neither of my writing tools work, so that's cool. Okay, 6 point what? 0 point what? Does it round to 0.06? Is that right? Now, when you got like standardized testing stuff, did they tell you you're in the 6.06 percentile? They probably just told you what? down 70 in your next play. Now, what are most of you going to do immediately? From here, you're going to do what next?
The same thing we did.
So you're going to literally start doing what?
Counting how many are there.
What would be easier here?
Things.
So, which is the first one that is not less than 70?
72.
Which is the first one that is less than 70? So what's the first one that's not less than 70? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them wouldn't be included. So 25 would be. What's that give me?
75.76.
So what percentile do you think that is? So you are basically rounding to the whole number when you do percentile. So this would be 76th percentile. So a lot of people miss that because they don't do the rounding part correctly. Now, I'm not going to do the third one. 2 is fine. The very bottom part, I wrote something like, this is a super, super generic way to find a percentile. This is a way to, by definition, technically find percentile, but almost always we're going to find it a better way. So you might just want to like keep that in the back of your head that like we're probably not going to use this method very much because there are much better ways to do it. But this is kind of like an overall. So about 6% of people in our class right now, what? About 6% of people in our class right now, what? Are shorter than 60 inches tall. About 76% of the people in this class right now are shorter than 70 inches tall. All right, so continuing over to the right side. Now we're going to figure out, it says, how does your height fall in relation to the mean? I would circle, underline something, it says to the mean. So now we're going to specifically compare ourselves to the mean. If an observation from a distribution, so let's just really quick, before we do anything else, find the mean height of the class and the standard deviation height of the class. So we did this yesterday. First button is what? Stat over to count. You're doing what?
One variable stat.
One variable stat.
Plus 1.
Plus 1. And I didn't mention this because we didn't need to yesterday. You can always put stuff in different lists if you don't want to delete it. You just have to pick what you're doing with. Alright, what is the mean of our class?
67.
Okay, so let's go to height. It says height something. Mean height. You'll see where it says that. So 60 what?
67.18 inches.
67.18 inches. Here it says standard deviation. Are you picking the one that's S or the one that's below that? Let's write symbols here. X bar equals. What symbol would I write here? And what is, I don't have to put it with my
3.84.
Say it again.
3.84.
I'm gonna, and especially as fast as we go this semester, I'm gonna try to start doing this a little bit more. We're gonna write some key things on the back. So go ahead and flip to the back real quick. It's supposed to say percentile, the best I can right now. in general, what did I say percentile is?
Percent better.
Percent. You did better than. Now, while I'm thinking about it, would it be appropriate to say that about 24% are taller than 70 inches? No. Why?
Because 70 inches is included in that 20%.
Because it would be 24% are as tall or taller with that whole inequality thing. Standard deviation. We learned what standard deviation is. We learned how to do standard deviation. But at the end yesterday in your class, I never wrote down a definition for what standard deviation is. When we found it, we started out by finding the what of the group, mean, and then we figured out how far away each one was from the mean, and the standard deviation ended up being what with those?
No, that's not.
The mean of those.
So it is the average distance from the average, from the mean. So those are two key terms from today as of right now. I'm going to try to keep remembering to flip back and forth and do stuff like that. All right, so we've got mean height, we've got our standard deviation for height. So let's say someone is, what's the first one we did? 66 is the first one I picked.
60.
On the left side, 60. If somebody is 60 inches tall, how do they relate to the mean? Very general. They're what? Less than the mean. Mathematically, how do we usually represent less than the mean? Or less than something? If yes, how else? If I'm less than, I went which way? So this way I'm going negative. So if I'm less than, I'm going negative. What about, what's the other one, 70? If I'm 70, where am I in relation to the mean? Which means I'm to the right, I'm positive. I know I haven't talked about z-score yet, but underneath the gap, the second sentence says observations larger than the mean are positive. Observations smaller than the mean are negative. That's what y'all just told me, even though we haven't talked about what a z-score is. So what we want to do is, this is now our new standard for essentially, and this isn't literally, but this kind of makes sense. This tells me where the bullseye is. This tells me how big each ring on the bullseye is going to be. So if my standard deviation is big, my bullseye is going to be really big, like each ring of it's going to be big. If my standard deviation is small, each ring is going to be really small. And then we care about where the points fall in relation to it. So we now bring that into an equation. I think I ended up deleting everything. So it says the z-score is and has a big gap. Alright, so we're going to have a value. And we said if the value is less, then it's going to be negative. So if I get negative, did I take value minus the mean or the mean minus the value?
Can you say that one more time?
I'm trying my best up here. That was not what it was just like interpreting which way we subtract with what you told me was negative positive. Alright, but then I don't know how big each ring is going to be. That's in relation to my standard deviation. So you divide by standard deviation. If you say you have a 90, a grade of a 90 in your AP Bio, and you have an 82 in your AP English, does that mean that you are and somebody says something like, well, that's not fair, our teacher grades a lot harder, or things are a lot harder in this class. You can't directly compare your 70, your 90 to your 85, whatever I just said, 82. So you can compare it relative to the class to then be able to compare it. Does that make sense? So like we're going to put it all in a level playing field to be able to compare the two
You can
grades.
compare English to other English scores.
We're going to make it where you can compare any class to any class because we can put them all on a level playing field with this. So this says, well, how did I do in relation to the mean? And let's fix it based off of the rings on our target to see really how we did. So that's why it's called standardized, which is the whole point of standardized test. It doesn't just take your score, it takes your score relative to the other ones who took the class, took the same test, and adjusts it to where you can compare. Most people don't know this, but SAT score depends on who else takes it, relatively. There's so many people that take it that it cancels out. But if you missed 3 questions on an SAT, and that was it, and you went and took the SAT again and you only missed 3 questions, that has nothing to say that your scores are going to be the same because of this. So if I rewrite a problem, even if I give you a SOX problem, if I give you guys one question, you guys one question, there are going to be a little differences, right? Like wording or something like that. Well, think about it, a whole SAT test. So they have to adjust for that. So they do this, they take it relative to all people who took it, and then adjust your score to spit it back out into an actual score. Like that's the whole process that takes place behind this. So that's why it is called standardized, because we are standardizing it to where it's something where we compare. Z-score is the same thing as standardized score. You might want to circle whatever there. So let's put into words what we did here. This told me about height. This part told me what? Just doing that, 60 inches versus 68.1, 67.1. Okay, above and below, what else?
The distance.
How far above and below, and then I took that, and if I divide it by standard deviation, it actually tells me, so I've got my target, I've got my rings. So here was our target at 67.18. So I think 60 would fall like here or something.
Yeah.
So it falls about, and without me going through and doing all math, about like 1.75 rings away from the mean. But each of these rings represents a what?
Standard deviation.
So what does this interpret to? The number of
Standard deviations.
you are,
Away from
and it tells you positive or negative. It says that on your paper, but I want to write it with these. Z-score, which is standardized score. Is the number of standard deviations from the mean and what direction. Now, if I'm like spitting out really quick recall stuff here, I'm going to say number of standard deviations for the mean, but the positive negative is just as important. I usually just don't say the full definition. Alright, so let's deal with the same numbers that we just did. So it says find a standard deviation or standardized score for the student who is. So to do my z-score, and right now I'm going to write it as my value, which is just an x value, minus the mean, which is what symbol? What symbol for mean?
That's the X bar.
What goes on the bottom?
Lowercase s.
The quicker you memorize this, the easier it's going to be. We use this from now till the last day you walk up class. So our specific x value was 60. Our x bar was,
67.82.
and our
3.8.
what?
3.84.
Now, obviously, when you type that in, you got to have parentheses over the top, or hit enter for order of operations there. We said it's going to be something like close to just under 2.
Negative 1.87.
So if I say, what does that mean to have a standardized value of negative 1.87, you would tell me that is
The standard.
1.8 standard deviations, more specific,
Under.
below the mean. And then the other one we did, 70, yes? It's getting worse. So if I asked you which one is more, what are the words I wanted to use? Or different, not uncharacteristic.
More of a difference.
Yeah. I can't think of the word I want to use.
A higher absolute value.
In general, if I say which one is most, I do want to see the wording because I have asked it this way in a quiz before. I don't know that I'm giving you that quiz, but I want to have my wording the same. Which is more unusual? So which one of those two would be more unusual? Why? Farther away, and it's farther away from the mean. So the z-score is farther away from the mean, so it is more unusual than this one. Does it have anything to do with positive, negative? No. So the bottom is an example like I talked about before. Jenny received 86 on her statistics test, which had a class mean of 80, standard deviation of 6.07. The next day, she received an 82 on her chemistry test, which had a mean of 76, standard deviation of 4. On which test did she have a higher score compared to her classmates? So, what should you do there? So go ahead and answer, do the math to answer that question. You can always add in subscript letters if you're using the same things and you don't want to get confused. Like we start doing that more and more, so you're not going to be able to read anything I'm writing right now. And then I can do the same thing with XC, X bar C, and so forth. So for statistics, what do I get as my z-score? Point what?
0.9.
Should you have looked at that one, known that's pretty close to that? That's how far away it is.
6.
This can go a little under one. What do I get as my z-score? You would have had all this written out, but what do I get as my z-score here?
ZCs. What you write for Z-score?
So like I did subscript S for all of these, and I'm gonna do C's for all of these.
Okay.
That's something I'm just kind of starting to throw at you. I'm not gonna come off if you don't do it right now, but the more we do stuff like that, the more it's gonna help you. So to answer the question, on which test did she have a higher score compared to others? Would my answer be chemistry, and why? Higher z-score. So like that is a test question I've asked before. Don't just say chemistry. Don't just share work. Chemistry because it was a higher z-score.
And that means that she did better than 1.5% or no?
No. We're gonna move to where you can kind of talk about like that. We're not there yet. So this won't make sense why I'm asking it right now, but it will later. What is the only information I gave you about the stat test? The class itself.
Class mean of 8.
The mean and standard deviation. Did I tell you anything else about that distribution? No. So where we wrote z-score back here, I want you to come write something that says can find / use regardless of shape. The next part that we're dealing with is we can do a lot more with the z-score only if it is a certain shape. So, but you can always find z-score and compare two things regardless of the shape at all.